The shipping industry is a major contributor to global greenhouse gas emissions. Traditional cargo ships rely heavily on fossil fuels, releasing significant amounts of carbon dioxide into the atmosphere. As awareness of climate change grows, the maritime sector is actively seeking ways to reduce its environmental impact and transition to more sustainable practices. Harnessing the power of wind propulsion offers a promising solution. Wind-assisted ship propulsion is not a new concept. For centuries, sailing vessels traverse the oceans using wind power. In recent years, there has been a resurgence of interest in wind-assisted technology as a means of reducing emissions and fuel consumption in modern shipping. This renewed focus on wind power is driven by a combination of factors, including rising fuel costs, stricter environmental regulations, and a growing demand for eco-friendly transportation solutions. Today, several companies and organizations are at the forefront of developing and implementing innovative wind propulsion technologies. These technologies range from traditional sails to sophisticated rotor sails and kite-based systems. Rotor sails, for instance, are tall, cylindrical structures that rotate to create a pressure difference, generating forward thrust. Kite-based systems use large kites to pull ships, reducing the load on the main engines. The International Windship Association, IWSA, plays a crucial role in promoting the adoption of wind propulsion in the shipping industry. The IWSA works to raise awareness about the benefits of wind-assisted technology, facilitate collaboration among stakeholders, and advocate for policies that support the development and deployment of wind-powered vessels. As the industry continues to explore and refine these technologies, we can expect to see a growing number of ships harnessing the power of the wind to reduce their environmental footprint. Wind-assisted propulsion offers significant environmental benefits by reducing greenhouse gas emissions from shipping. By harnessing the power of the wind, ships can decrease their reliance on fossil fuels, leading to lower carbon dioxide emissions. The extent of emission reductions achievable through wind propulsion varies depending on factors such as wind conditions, vessel type, and the specific technology employed. Studies conducted by the IWSA and other organizations have shown that wind-assisted systems can reduce fuel consumption and emissions by 5% to 30% or more. These reductions translate into substantial environmental benefits, contributing to global efforts to mitigate climate change. Furthermore, wind propulsion technologies produce no harmful air pollutants, improving air quality in port cities and along shipping routes. As the maritime industry strives to meet international emission reduction targets set by organizations like the International Maritime Organization, IMO, wind-assisted technology is gaining recognition as a viable solution. The IMO has established ambitious goals to reduce carbon intensity in shipping by at least 40% by 2030 and to achieve net zero emissions by 2050. Wind propulsion aligns with these goals by providing a clean and sustainable alternative to conventional fossil fuel-powered engines. By reducing the industry's reliance on carbon-intensive fuels, wind-assisted technology can play a crucial role in decarbonizing shipping and achieving a greener future for maritime transportation. The economic benefits of wind-assisted propulsion are becoming increasingly apparent to ship owners and operators. While the initial investment in wind propulsion technology can be significant, the long-term savings on fuel costs can outweigh the upfront expenses. As fuel prices continue to fluctuate and environmental regulations become more stringent, the economic case for wind propulsion becomes even stronger. The payback period for wind propulsion systems varies depending on factors such as the type of technology, the size of the vessel, and prevailing wind conditions. However, studies have shown that payback periods can be as short as a few years, particularly for vessels operating on routes with consistent wind patterns. Beyond fuel cost savings, wind-assisted technology can also reduce maintenance expenses associated with conventional engines. The adoption of wind-assisted propulsion is steadily increasing across the maritime industry. A growing number of shipping companies are incorporating wind propulsion technologies into their fleets, recognizing the environmental and economic advantages. Examples include large cargo vessels, tankers, and even cruise ships. Several factors are driving this trend, including government incentives, technological advancements, and a growing awareness of the benefits of sustainable shipping among cargo owners and consumers. As the industry gains experience with wind propulsion and the technology continues to mature, we can expect to see even wider adoption and integration of wind-assisted systems in the years to come. On the horizon are winds of progress advancements in wind-assisted technology. We delve into how the field of wind-assisted ship propulsion is constantly evolving. With ongoing research and development efforts, companies and research institutions are exploring innovative designs and materials to optimize the performance of wind propulsion systems. One area of focus is the development of more efficient rotor sails. Rotor sails have proven effective in harnessing wind energy, but researchers are working to enhance their aerodynamic properties and reduce drag, further improving fuel savings. Another area of innovation is the development of advanced control systems that optimize the use of wind power in conjunction with the ship's main engines. These systems use sophisticated algorithms and sensors to adjust the sails or rotors in real time, maximizing thrust from the wind and minimizing fuel consumption. Kite-based propulsion systems are also undergoing significant advancements. Researchers are developing larger and more durable kites capable of withstanding harsh marine environments. Additionally, they are refining control systems to automate kite deployment and retrieval, simplifying operations and making kite-based systems more user-friendly. Lastly, the development of hybrid systems that combine wind propulsion with other energy-saving technologies, such as solar panels and battery storage, is another area of active research. These hybrid systems aim to further reduce emissions and enhance the overall efficiency of ships, paving the way for even more sustainable maritime transportation. In charting a course toward a sustainable future, we explore how wind-assisted propulsion holds immense potential to transform the shipping industry and contribute to a more sustainable future. As the technology continues to advance and gain wider adoption, we can expect to see a significant reduction in the environmental impact of maritime transport. The transition to wind power aligns with global efforts to combat climate change and reduce our reliance on fossil fuels. Collaboration among stakeholders, including ship owners, technology providers, policymakers, and research institutions, is crucial to accelerate the adoption of wind-assisted propulsion. Governments can play a key role by providing incentives, establishing supportive regulations, and funding research and development initiatives. The International Windship Association, IWSA, continues to advocate for the widespread adoption of wind propulsion and to promote the development of innovative wind-assisted technologies. The IWSA works to raise awareness about the benefits of wind power, facilitate knowledge sharing, and foster collaboration within the industry. As we look to the future, wind-assisted propulsion is poised to play a pivotal role in creating a cleaner, more sustainable shipping industry. By harnessing the power of the wind, we can chart a course toward a greener future for maritime transportation and contribute to a healthier planet.